So that's the question number 5 from 4/1 May-June 2024. The A part describe how a longitudinal wave differs from a transverse wave. So for the 2 marks, we need to differentiate between the longitudinal and the transverse wave. That the definitions may be good here. The longitudinal wave, the particles vibrate parallel to the direction of traveling of the wave, and transverse wave, the particles vibrate perpendicular to the direction of propagation of the wave. And we can also mention that in longitudinal wave we have compression and rarefactions, while in transverse wave we have crusts and troughs. You can also mention here that the longitudinal wave need a material medium. B bar. Fig 5.1 represents a seismic wave produced by an earthquake. By looking at the diagram, we can see that this is a longitudinal wave, and as per the prior understanding and knowledge, the P wave was the longitudinal wave. State whether the seismic wave is a P wave like primary or S wave secondary. Justify your choice. So yeah, this is a P wave, this is a longitudinal nature wave. Alright, moving towards the next part. The wave represented in figure 5.1 has a wavelength of 1.2 × 10⁴ meter. Calculate the actual distance between point J and point K. Now let's go back and see from one compression to the next compression one wavelength, and from here to the next rarefaction we have 1.5 wavelength. The distance is 1.5 wavelength. Alright, and the distance, the value of one wavelength is given 1.2 × 10⁴ meter. Calculate the actual distance between the point J and K, and the actual distance was 1.5 times wavelength. Just substitute the value of the wavelength here, we will get this as the 18,000 meters or 18 kilometers. Okay, number 3. The wave in 2 travels through a ground at a speed of 4600 meters per second. As the wave passes a certain point, the ground completes 5 oscillations. Calculate the time that it takes for the wave to pass. Means we have to calculate the time for 5 oscillations. Show your working. Whenever we have a question that has something written like show your working, and we need to do all the steps. Okay, so like we start with the V is equals to F lambda, the wave equation. So simplify it, find the F as V by lambda, substitute the value. V was 4600, was given the data, and the lambda, as it was mentioning the 2, so wavelength was given as 1.2 × 10⁴ meter here. Okay, so we'll get the frequency as 0.38. From the frequency we can find out the time period for one wave. So we have a relation, time period is equals to 1 by F. So T is equals to 1 by 0.38 will give you the time period for one oscillation, but the question was for 5 complete oscillations. So what we need to do, we need to just simply do one thing. We need to multiply this time period for the 5 and get 13 seconds, and this is our answer. This is a little bit complicated question that normally students find it difficult. So look at the question, follow the command words, and work out the value for whole wave, like the 5 number of oscillations.